Hi, I'm Paul Battaglia, and this is section 4.6, graphs of other trigonometric functions. What I like to do in this section is maintain some continuity from section 4.5, where we talked about the graphs of sine and cosine functions, to this section, 4.6. And the way I do that is actually by starting to graph secant and cosecant functions first, because they're so closely tied to the graphs of the sine and cosine function. And I have with me today Gabe and Brittany, and they're going to talk to you a little bit more about how they structure their class when talking about these specific graphs. And Brittany, I know that you like to do something with your students to stay organized as they tackle these graphs, right?
Yeah, so before they even create the graphs, I like to make sure that they start out with figuring out what the domain, the range, the period, and everything else that goes along.
All that key information.
Yeah, the key information.
Asymptotes.
Yeah, any asymptotes and everything before in a nice little table.
Okay, and that's a new feature now, because now they didn't have to worry about those with the sine and cosine graph, and now here we are introducing them to the secant and the cosecant graph, and they're starting to see how it relates, but at the same time, we're introducing asymptotes into the idea because of the function itself. So I like that. What about the cotangent and the tangent functions, Gabe?
So as far as tangent and cotangent goes, I like to take it all the way back to the unit circle.
Okay.
So I like to have my students just have a blank Cartesian plane, and then what we do is we go through some sort of guided activity where I'll sort of walk them through graphing these two functions. And how we'll do that is, well, we'll say, let's lay the angles out along the x-axis, and let's talk about, well, maybe tangent first. So we'll think about the function y equals tangent of x, and we'll move through the unit circle, and we'll go ahead and we'll plot the points that we can for tangent. And what we'll see is that there's a couple points where maybe tangent's undefined as we're going around the unit circle. So this is a good opportunity for me to reiterate the idea of these vertical asymptotes. And it's something a little different that they haven't seen before, where they've seen vertical asymptotes when talking about rational functions, but now we have like infinitely many vertical asymptotes, we have periodic functions, we have a lot of good stuff to talk about here, and I think I like to then sort of tie these ideas back into what Brittany was talking about, with keeping the students organized as they're trying to graph these functions. Because if you just throw them out there and say, graph y equals 3 tangent of 2x plus 7 minus 82, it's sort of, it becomes overwhelming. But if they're like, okay, I know where to start. I want to start by looking for the period, or I want to start by looking for where the asymptotes are.
And that's really important with the cotangent and tangent with the vertical asymptotes, because they can change.
Yeah, that's really important. I think as we go and introduce more things into the graph, phase shifts or what have you, now, all those patterns are changing. And I think maybe the one other thing I would add to, and this is really more if you have time, is that when Gabe was talking about the asymptotes for tangent, let's say, now students have the idea in their head, because they've learned that there's an identity, and that tangent is equal to sine x over cosine x. And so I think you said rational function connection, Now, it's not quite a rational function. However, the idea that the denominator could be 0 at some points, I think that would really help them if they could see where that's happening and why the vertical asymptotes are occurring where they are. That'd be helpful. So I hope you found these tips helpful and you find much success in section 4.6.